Alrighty then, I got the wiring diagram. Woohoo! And speaker, blue-black. Good. Triggering, black-purple. So that's these two wires here. Then I can use to trigger the generator. So I'll have to see what the triggering mechanism is. Typically it's these over here that are unmarked, I would say, on function, common, and ground. Current keeper we're not using. Okay. It may not have that capability, but usually it does, and so we'll see if we can find that. Anyways, okay, so let's moving right along then. We need to find out why the motor isn't running, because the motor actually should be running with current sent to it. So let's test the motor leads out directly with current. Maybe I've pinched a plastic in the wire. So let's take them out one at a time. And actually what we could do is we just apply power, about 10 volts, and then let's test the voltage going to each one of these to see what's happening. I'm using the voltmeter here, plus 20 volts. So these two leads are going to be right. This is going to be 10 volts coming in. Otherwise the light wouldn't come on. So what's going on here? So this is negative, this is positive to the motor, and it says nothing is going to the motor. All right, well, let's troubleshooting this. Let's take one of the leads out from the motor. And let's just touch it. Well, doesn't seem to be a problem. Take the other one out. And then just touch the tops here. Nothing seems to be working. Okay, let's take the plus and minus here and just make sure that we've got appropriate contact all the way through. Here's minus, here's plus, and motor. Okay, so something in the decoder is not functioning for whatever reason. It could be set up so that it is not sending motor voltage because of its CV29. CV29 says, will it run in analog mode, yes or no? So that could be the problem. Let's go ahead and hook the motor back up. We know it's functioning. We know these are the proper two leads that it's supposed to go to, here and here. Okay. See if we can drag. We're going to drag DCC over here, and we're going to check the settings to see what the decoder is using. So give me a minute to set that up. Okay, well, I can't be in the picture and do this because it somehow needs to be tethered, but you can see that I've selected engine number 3 here, and using the throttle, we're moving it up. Nothing's happening here, except when I plug it in, which is kind of unusual. So when I plug it in and it's tethered, and it's running fine. So Now let's go check CV29. Can't show this to you again. We've got some issue here, but program, and we're going to look at CV29, and I suspect it's going to have a display, and it says no ACK, so it can't even get the information for whatever reason. I'm going to go ahead and make it ordinarily what it would be is a 6. And see if we can force that. I don't see anything happening there. Let's then go back to make sure it's still running. Yes. Okay. And I'm going to take it off of DCC and plug it into DC. So let's do that. Unhook. And plug it into our DC system. Now the only thing I changed was I changed CV29. So and evidently that did not fix it. So we're going to do some more research here. Let's see what's going on. All right, checked CV29, and it was 6. We're going to ensure that. I'm going to go into operations mode programming, and I'm going to do 29 and force it to be 6. And we're going to enter that and see what happens. Says good, and I noticed the 12, CV12 needs to be at least a 1, so we're going to force CV12 to be a 1, and enter. That looks good. All right, now let's go back to analog mode. Pulling this and this. And plugging it in and see if we get analog. 5 volts, 6 volts. Aha! A winner. So the issue was CV12 was not set to 0. There we go. Something else is going on there. All right. So let's continue on with the lights. So give me a second. Okay. I'm back. It's time to figure out which ones are the lights. Now, usually, this is kind of interesting, but usually the lights, right, are white and blue. No white and blue here. I'm going to go ahead and cut these because most of them go to switches and other things there that doesn't really matter. I'm going to cut them off. And let's try a couple things here. It doesn't really tell us on the connectors what goes to what. We've got some heavier duty ones here, which I assume go to the smoke unit, but we'll find that out in a second. Let's look at the front light. Ordinarily this would be a, again as I said, a slam dunk with the blue wire being the common and the white wire. Now, you know what we can do? We can go back to the connector. We can go back to this guy and we can look at where the wires go. Aha! So ordinarily we could ring out, go back to continuity check, and we got the continuity checker here, and the blue wire, right? So How many of you know what your NMRA standard is? The blue wire here would go to the blue wire. Where's the connector? I just pulled it out and threw it away. Here's the connector. This will give us a reference. And according to this, the blue wire would be the third wire. So going from here, right, blue wire to the third wire, wasn't it? Okay. So the blue wire is not it. So let's try this one and see if we can get any continuity with any of these connectors here. No, let's try this one. No. Well, all right, let's see if we've got any common value. So it looks like the three that are connected are this one, and this one. So this would be blue if it was going to be anything. And this one would be white and yellow, and this probably would be white. Following that over here, well, let's pin this one out. Let's see if we can go from the white one right again to any of these. Make sure this is working. Yes. None. Well, let's see if there's even a resistor in series with any of these. Doesn't show any. Let's go to a 2K and just look for resistances. And you can see me trying each one here. Don't seem to be having any luck. Okay. Oh! Something there. Alrighty then, that would be the red wire. All right, let's go again to continuity. Check from here to the red wire. Ah, continuity, 1.4 ohms. Let's turn this around. .4 ohms. Okay, let's try this one. This one. This one. Interesting. Okay, so it looks like the red wire is positive. So not quite sure how that's gonna play out here. Is it positive for what? For the front light? We may have to tear it apart to find out what the front light is. It does not show it on the diagram as to what the colors of the wires are. It just says that there's a board 201028. I don't know what that's all about. I guess that's the switches that are in there. Maybe it's one of these is the common. Let's see if we can. And again, that would make sense because the common, right, should go to the smoke unit also. Interesting. Okay, we're getting nothing to any of those. See if we can go from the other side. Let's see if we can find the light. I'm gonna make a guess. I'm gonna say red is to one side of the light and yellow is the other side. Again, this is not NMRA standard, but very well could be. I'm just going to do well, I'm going to do a diode test, which is, this is a diode, so red to red. Okay. Nothing. And turn it around, and we get nothing. So those two are not the right ones. I've also got blue out, so let's try the blue to yellow. Nothing. Reverse that. Nothing. I may have to just take the light out in order to figure this out. So not quite sure what to do. See if maybe there's a way to get up inside of there. Be right back. All right, so I fooled with this a little bit, and the front came right out. When I pushed on it, the front came out. So there's the circuit board that I was looking for and all the wires, and I have already disconnected the two wires for the light. So I'm just going to extend those on the back. But now the question is, how much of this do I keep? Do I keep the smoke on, off? I don't know. I could not keep any of it and just have the smoke unit separate from it. So we'll think about that tonight. I'm ready to go to dinner, and we'll work on this tomorrow. Okay, so last time we left it, things were working well under AC. We need to clean up a couple of the leads. We've got extra leads coming out here, so we need to fix that. I'm going to put all the reds together and all the blacks together, and I'll be back in this shortly. We're back, and as you can see, I've put together the red wire and the black wire and brought them together here and here. This is typically the way I'll do red and black together. I'll solder them, trying to keep the directions of the wires the way they were, and without creating too many buckles and problems. So this looks like it might be ready. It's still got the AC or DC power supply hooked up to it. So let's just test it, make sure that we haven't messed it up. Blue light's on, that's good. Increasing, there you go. Looks good, sounds good. All right, so we're in good shape with that right now, and let's take our attention now to the front end, which is up here. I've taken apart found that I could pull the smoke box off. I don't remember if I did that in the last video or not, but this has switches in the center. If you can see that, the switches are smoke. So let's see if we can. Oh, I can't do that. All right, yeah, there's just smoke and on off, and then polarity. Interesting. All right. So NMRA standard is right rail red, left rail black. Large scale is, according to this, would be just the opposite of that. Or in the center would be off. And you might say, well, why would you want off? Well, some people use battery power, and so you don't want to pick up from the track at all. So this really is track pickup more than anything else. And so we don't need that at all, because we're picking up from the track here, we're going through the decoder here, right, and then back to the motor through the orange and gray wire here and here. That's orange. Looks yellow in the camera for some reason, but orange and gray. So going back to the smoke box, and what we're going to do there is I'm just going to cut all this out, because yeah, what are we doing with this? We're going to have to play a little game with the smoke system to where we can use the, well, smoke. I don't know if he's going to use DC. I may have to rethink this. Maybe I'll leave that smoke switch on there, but we certainly don't want the polarity, and we got a bunch of stuff's going on with this with the wiring that's going in here, and I'm not quite sure. We certainly don't need any of these connectors, these old connectors that were there. I've already cut one off, cut the other one off too. And then the two leads that are coming from the headlight, I'm going to go ahead and hook those up back this way through and down to the light connections, and then put the appropriate resistors in there for that, so we can get all that squared away so it comes off of there. All right, so I'm going to go ahead and cut those wires and see if I can figure out a way to do this switch, leave that smoke switch there, because again, we may want to turn that off for DC operation. Okay, so with none of these leads being the right colors, I mean, I would expect blue to be positive, and it's not. I would expect there to be a white wire for the front headlight. There is no white wire. These bigger wires look like they're coming, plus and minus would come from the track. And so I don't know whether or not I'm going to do that or not. The yellow and orange or orange and gray are certainly not appropriate. I'm going to go ahead and remove these and these, and then I'm going to put this is my plan right now, and then I'm going to go ahead and put the headlight back where it belonged here and here, and it even says up inside here plus and minus LED, and I'm going to redo the wires so that the wires are the correct color, according to NMRA standard anyhow, and we'll go back. Okay, so sometimes you just have to try things, and in this particular case we have a smoke unit, and this smoke unit probably draws an amp. I could actually run it on the machine here and check it out and see what we've got. Looking at the paperwork from our friends at Soundtraxx, and they say, oh, if you're going to do a smoke unit, this is what you want to use. And this is on their website. And they show that on the function output from the decoder, any function output is only good for 100 milliamps, and they even say that there. So regardless of saying Tsunami digital sound decoder, but this is a Tsunami 2, and so it's limited to 100 milliamps. That's typical for some of them. This one probably is a little bit more, but beside that, I'm going to try this. This smoke generator is going to draw more than 100 milliamps because all it is a heating element. So notice that there are several things going here. One is they show a diode. So hopefully you can see that. They show a diode here. on the coil, right, of the relay. So here's a relay here, single pole, single throw relay, and then here's the smoke generator. Well, we've got to put, there's another switch that we're going to put in there that's going to come up the front, and it says to motor pickups, motor terminals, or track pickups. See the text. We're going to do it to the track pickups. The motor pickups then would go through the decoder on the other side, and that would add current to the motor. We don't really want to do that if we can help it. So looking at this scenario here and thinking about what diode we're going to add, I have several of these really cool little relays in stock. And I don't know if you can read that, HFD 31/12. Well, it's a 12 volt relay that will give you 1 amp, right, at 30 volts. Well, we're not going to do 30 volts. We're at 13 or 14 volts, and track voltage even then. So 1 amp is plenty good enough for what we're doing. It's got pinouts at the bottom, so it's just these pins, and so we're going to have to kind of play a game with the pins. The little black bar here gives you the orientation of the pins. So then taking this sheet, putting aside the technical bulletin here and looking at the sheet for this particular device, it shows here, right, single side stable, bottom view, right? So we turn it over, and here's that black bar, right? So knowing where the black bar is, just turning it over here, and what we see here is O plus or minus, because in fact there's a diode in here. They already put a diode in there because in most situations where you're running DC, you have this they call the collapsing condition, where the inductor, which is the wires in the relay, when they collapse, they create energy on the other side and create problems. So this is already a solid state device, and it already has a diode in there. So it only works if you put plus here and minus here. And as we see on this, right, this band here is the plus, right, and this down here says minus. I know it doesn't say that, but you can read electronic. This band here is the plus side. So function common blue is always plus, so this is a plus, this is a minus, and that works out for us here. So what we're going to do is we're going to go ahead and install this pin and this pin, and then we're only going to use one of these. I mean, either 2 and 3 or 3 and 4, or, well, actually when it's engaged we want it to work, so that means this is its stable state. It's de-energized, so when it's energized we want 3 and either 3 and 4 or 8 and 7, so either these two or these two pins, and we're going to use those for the smoke unit. So with that, and without further ado, we're going to wire this in, and so we're going to have to try to find a space for this somewhere, and maybe right here would be appropriate. Somewhere it's out of the way, and we're going to have to look up inside there and see what's there so that we don't mess that up.